Deserts, vast and seemingly barren landscapes, often conjure up images of endless sand dunes, scorching heat, and a lifeless expanse. However, beneath the surface of these dry and arid regions lies a fascinating world shaped by unique environmental forces, biology, and history. The science of deserts is not just a study of sand and heat but an exploration of the incredible adaptability of life and the powerful forces that shape Earth's driest habitats. From the deserts of Africa to the American Southwest, these regions tell a story of survival, resilience, and an ecosystem finely tuned to endure one of the planet's most extreme environments. Deserts are defined by their lack of moisture. Technically, any area receiving less than 25 centimeters, 10 inches, of rainfall per year is considered a desert. This lack of water is the primary characteristic that unites the world's deserts, but not all deserts are hot. There are cold deserts, like Antarctica and the Gobi Desert, where temperatures plummet far below freezing. Whether hot or cold, all deserts share the common challenge of extreme dryness, and this aridity shapes everything within them, from the soil and plants to the animals and even the weather. The creation of a desert begins with a combination of factors, including geography, wind patterns, and atmospheric conditions. Most deserts form in regions where dry, descending air prevents moisture from accumulating. One of the key drivers of desert formation is something known as the Hadley cell, a large-scale atmospheric circulation pattern. In this process, warm, moist air rises near the equator, where it cools and releases its moisture as rainfall. The now dry air then descends around 30 degrees north or south of the equator, where it creates high-pressure zones with little to no rainfall. This descending air is responsible for the dry conditions that give rise to many of the world's great deserts, such as the Sahara and the Arabian Desert. Deserts also form in areas that are blocked from moist air by mountain ranges. This phenomenon, known as a rain shadow, occurs when moist air is forced to rise over a mountain range. As the air rises, it cools and loses its moisture as precipitation on the windward side of the mountains. By the time the air descends on the leeward side, it is dry, creating arid conditions perfect for the development of deserts. The Great Basin Desert in the United States is a classic example of a rain shadow desert, as it lies in the shadow of the Sierra Nevada mountains. Once a desert forms, it is shaped by powerful forces such as wind and occasional water flow. Wind is a primary sculptor of desert landscapes, capable of moving large amounts of sand and dust over great distances. In many deserts, the wind is responsible for the creation of dunes, massive, ever-shifting hills of sand that can rise hundreds of feet into the air. The famous dunes of the Sahara Desert are some of the largest and most iconic, but sand dunes can be found in many other deserts around the world. These dunes are constantly on the move, as the wind picks up grains of sand from one area and deposits them in another, creating a dynamic and ever-changing landscape. In addition to wind, water, despite its scarcity, also plays a critical role in shaping desert landscapes. When rain does fall in the desert, it often comes in the form of sudden, intense storms. These storms can lead to flash floods, or water rushes through normally dry riverbeds, known as wadis or arroyos, with tremendous force. This water carves through the desert, eroding rock and soil and creating canyons, gullies, and other dramatic landforms. Over time, these rare but powerful water events have a profound impact on the structure of the desert. The soil in deserts is as unique as the landscape. Deserts often have what is known as aridisol, a type of soil that lacks organic material and is low in nutrients. This is largely due to the fact that there is very little plant life in most deserts to contribute organic matter to the soil. The harsh conditions also prevent the buildup of decayed material, leaving the soil sandy, rocky, and often salty. In some deserts, like the Atacama Desert in South America, the soil is so dry and devoid of nutrients that it resembles the surface of Mars more than any other place on Earth. Despite these harsh conditions, deserts are not lifeless. In fact, they are home to a remarkable array of plants and animals that have adapted to survive in some of the most challenging environments on the planet. The ability of life to persist in such an environment is one of the most fascinating aspects of desert science. Plants in the desert have developed extraordinary strategies to cope with the lack of water. Many desert plants, such as cacti and succulents, have evolved to store water in their tissues, allowing them to survive long periods of drought. Some plants, like the creosote bush, have deep root systems that can tap into underground water sources, while others, like certain desert wildflowers, remain dormant as seeds until the rare rains come, at which point they spring to life, bloom, and reproduce in a matter of days or weeks before drying out once again. Cacti are perhaps the most iconic of desert plants, with their thick, fleshy stems and spines that serve as protection against herbivores and help reduce water loss. The saguaro cactus, native to the Sonoran Desert, is one of the largest cacti in the world and can live for over 200 years. Its massive arms store enough water to sustain the plant through years of drought, making it a symbol of desert resilience. Animals in the desert have also developed unique adaptations to survive the extreme heat and lack of water. Many desert animals are nocturnal, meaning they are active at night when temperatures are cooler. During the day, they retreat to burrows or shaded areas to avoid the scorching heat. Some, like the kangaroo rat, have evolved to extract all the moisture they need from the seeds they eat, meaning they never have to drink water. Others, like camels, are capable of storing fat in their humps, which can be metabolized into water when resources are scarce. Reptiles, such as lizards and snakes, are particularly well suited to desert life. Their scaly skin helps reduce water loss, and their cold-blooded nature allows them to regulate their body temperature by basking in the sun during the cooler parts of the day and seeking shade or burrows during the heat. The desert tortoise, found in the Mojave and Sonoran deserts, spends up to 95% of its life underground in burrows to escape the heat. Insects also thrive in desert environments, using a variety of strategies to cope with the extreme conditions. Many desert insects, like the Namib desert beetle, have evolved ways to collect water from the air. This beetle has a special adaptation that allows it to capture moisture from the morning fog on its back and channel it into its mouth. Other insects, like ants and scorpions, have evolved to be highly efficient hunters, making the most of the sparse food resources available in the desert. Birds, too, are common in the desert, although they have to be highly mobile to find food and water. Some desert birds, like the roadrunner, are able to get most of their water from the food they eat, while others, like migratory species, travel great distances to find water sources. The ability of birds to fly also allows them to escape the extreme heat by moving to cooler areas during the hottest parts of the day. Beyond the biological adaptations, the human relationship with deserts is equally fascinating. For thousands of years, humans have found ways to live in deserts, from the ancient civilizations that flourished along the Nile and Egypt to the nomadic tribes of the Arabian Peninsula. The ability to adapt to the desert has often meant finding ways to harness the sparse water resources available, such as using irrigation to grow crops in otherwise barren soil. Modern technology has allowed humans to thrive in desert environments in ways that were previously unimaginable. Cities like Las Vegas and Dubai have risen out of the desert, thanks to advances in water management, air conditioning, and transportation. These cities stand as testaments to human ingenuity but also raise important questions about sustainability. As climate change accelerates and water becomes an increasingly scarce resource, the future of desert regions and the people who live there is uncertain. Climate change is also having a profound impact on deserts themselves. While deserts are naturally arid, some are becoming even drier as global temperatures rise. This can lead to desertification, the process by which fertile land becomes desert. Desertification is a growing concern in regions like the Sahel in Africa, where overgrazing, deforestation, and climate change are turning once productive land into desert. This has serious implications for the people and animals that depend on these ecosystems for survival. Interestingly, the study of deserts also provides insights into other planets. The extreme conditions found in deserts on Earth are similar to those on planets like Mars, where scientists believe deserts cover much of the surface. By studying desert ecosystems on Earth, researchers hope to better understand the potential for life on other planets and how life might adapt to survive in such extreme environments. In many ways, deserts are the perfect laboratories for studying the resilience of life and the forces that shape our planet. The science of deserts encompasses a wide range of disciplines, from geology and meteorology to biology and ecology. By studying deserts, scientists gain valuable insights into how ecosystems function under extreme stress and how organisms can adapt to survive in some of the harshest environments on Earth. Deserts may seem desolate and uninviting at first glance, but they are rich with life, history, and science. The adaptations of desert plants and animals are marvels of evolution, demonstrating the power of nature to survive even in the most challenging conditions. The landscapes themselves, sculpted by wind and occasional water, are a reminder of the incredible forces at work beneath the surface of our planet. And as humans continue to explore these vast, arid regions, we are reminded of both the fragility and resilience of life in the face of adversity. Deserts, in their stark beauty, teach us about the limits of endurance, the necessity of adaptation, and the interconnectedness of all living things.